Hey guys, welcome back to Maths Recovery with Rebecca. Today we are going to be looking at factorizing trig equations. Generally these are quadratic equations, but we'll see what we get. Okay, so the first thing that we need to take into consideration is we need to go back to factorizing, go through all of our videos, how to do binomial factorizing, how to do trinomial factorizing, and even sum and difference of cubes, which I see is not on this list, but it's something that needs to be, and you need to go over. It's not very common, but you know, who knows? Okay, let us look at the first one here. So the question is going to say, determine the general solution, and it's going to be like this. Great. So let's take a look. Yeah, the question is written for me. 3 sine theta is equal to minus 2 cos squared theta. And we've got our important identities that we are aware of. The tan theta is equal to sine theta over cos theta. The sine theta plus cos theta is equal to 1. And the two variations of how we can manipulate that second equation to suit us. Okay, so let's take a look. The first thing that we need to try and accomplish is to get only one ratio. So either everything is just sine, just cos, just tan, and we need to make that our goal. So if I look at my identities, it's important to see that this cos squared theta can be changed into 1 minus sine squared theta, and that's going to make this whole equation into sines. Then I'm going to break that bracket. And then I see it's quadratic because my degree there is 2. But let's just go, I'm going to make a little side note here. So some of you guys might not be able to visualize it, but in your head, I'm going to say let x equal to sine theta. So we can just get a better visual representative of what we're looking at here. Oops, that is supposed to be just the x. And x squared. Do you see the quadratic, the square? So what we would normally do is just go and put it in standard form and then factorize from there. So when we factorize, if you've got the white calculator, mode 5-3. If you don't, you'd have to use the AC method, which is fine. So this is going to factorize to x minus 2 and 2x plus 1. And that's the same process that we're going to follow over here. So let's go back to our red. So 2 sine squared theta minus 3 sine theta minus 2, and then I am just going to factorize, and it's going to be in the same format as this. So it's going to be sine theta minus 2 and 2 sine theta plus 1. And remember, when we're working with quadratic, we break it up over that multiplication there. So I'm going to get sine theta is equal to minus 2. It's plus 2 because you're going to make sine theta minus 2 equal to 0 and then move it over. Or you're going to have 2 sine theta plus 1 is equal to 0 and then move everything over. These are just basic linear equations. Minus half. Let's break this up for ourselves. So we're going to have 4 answers here. First of all, we've got to realize that this is now restricted. If I look at the basic sine graph, because that's what this is, right? This is just the basic sine graph, and it's telling us that it's looking for the y value of 2. If I just look at my sine graph, the max sorry, that this graph could be at is a y value of 1. So I can see straight off the bat that this is going to be no solution, but this side should be able to work. So remember, our reference angle is in quadrant 1, so it'll just take the half, and if you arc the half, we are going to get 30. That's our reference angle. What quadrants are we in? We are in quadrant 2 and, no, negative is quadrant 3 and 4. Quadrant 3, let's take a look. What is the reference angle in quadrant 3? Well, our reduction angle in quadrant 3 is just going to be 180 minus 30, which is just going to be 150 plus k times. And then what is our period of sine? Just 360. Or we're going to be in quadrant 4. And that is 360 minus, so that's going to be 330 plus k times 360 k's. Great. Let's move on. Okay. Looks like the same concept here. Remember, we've got to try and make everything either sine or cos. I'm going to change this to that identity. Remember, you can pause these before I start them and try them out yourself. Hopefully you are seeing the quadratic, which means we've got to move everything over to the one side. I'm going to move everything over to the right-hand side, so this can be a positive, because we want to try and get that first term to be positive to have it in standard form. So I'm going to have 4 minus 6, which is going to be a minus 2. There it is in standard form. Let's go and factorize. Guys, when you factorize this thing, if you ever come up to getting the actual quadratic formula, you have made a mistake. So just be very aware of that. These are already worth 7 marks, hence the 7 over here. If you have quadratic formula, you're factorizing, you've messed up on your trying to get it into standard formula somewhere. This is going to be cos, oops, there's a 2 there in front. It has to be a 2 because it has to be a 6. Okay. 2 cos x plus 1. Great. Then we're going to break it up over the multiplication. So I'm going to get cos of x is equal to 2 over 3, which is valid because, again, cos, if we look at the function, cos function looks like that, and it has a min of -1 and a max of 1. Okay, let's look at this side. Cos of x is equal to -1/2. Again, that is valid. So let's look at our 4 solutions. So let's find our reference angle over here. Just going to arc that. Shift cos 2 over 3, and I'm getting 48,119. Let's look at what quadrants we'll be in. So we'll be in quadrant 1, which is just, oh, this is x. Don't make that mistake, because you're not solving for theta, you're solving for x. X is equal to, quadrant 1, remember, is just the acute angle. This is cos, its period is 360, and k is an element of integers. Let me take that line away, because now it is interfering with my equation. There we go, it is gone. Or we're going to be in quadrant 4, which is 360 minus our angle, our reference angle, and I'm getting 81 plus k times 360 k's. Okay, let's look at the other side here. Let's look at trying to find the reference angle. Remember, the reference angle is going to be in quadrant 1. The sign, the negative sign there, just tells us that we're going to be in this negative. We're going to be in quadrant 2 and quadrant 3. So in quadrant 2, it's just going to be 180 minus 60, which is 120 plus k times 360, because that's the period of cos. Or in quadrant 3, our reference angle is 180 plus, so 180 plus 60 is 240 plus k times 360 k's. Great, 7 marks in the bag. Next one, pause it, try it yourself, see what you get. Okay, so what I'm seeing is a lot of double variables going on here. What happens if I take out a cos? Because I mean, this is a binomial. So let me take out a cos, and I'm left with 2 sine x minus cos x is equal to 0. There's that. So I've got a cos of x is equal to 0, or 2 sine x is equal to cos of x. The situation is the tan ones. So if I divide both sides by cos, I'm going to get 2 tan of x is equal to 1, and then tan of x is equal to a half. There's no restriction on the tan graphs, they are infinite. So that's that. So let's look at the reference angle here. Cos of 0 is 90. 0 is always classified as positive. Ooh. So let's go look. So we're going to be positive in quadrant 1, which is just 90 plus k times 360 k's. Or we're going to be positive in quadrant 4, which is 360 minus 90, which is just 270 plus k times 360 k's. Okay, let's go look at the other side here. The reference angle for tan of half is 26,57, and tan is positive in quadrant 1. Oh, have I done it again? Yes, I have done it again. It's a good thing that I picked up on it. I can quickly just correct it. Everything is supposed to be an x, which is fine because I picked it up before I said it's done. So if you do that, you'll be fine. Okay, so it's 26,57, but tan repeats itself every 180. That's its period. Or where else is tan positive? Tan is also positive in quadrant 3. So that's going to be 180 plus this 26,5, and I'm getting 206,57 plus k times 180 k's. Great, 6 marks, guys. Hey guys, let's look at this last one. So I'm seeing that if I'm trying to make everything the same variable, there's a chance that I could probably try and make this sine squared x into 1 minus cos squared x, but then I've still got this double variable going on here. Let's go And oh, do you know that 2 is the same as 2 times 1? And 1 is equal to sine squared theta plus cos squared theta, or x in our case. I wonder if that's going to be any help. Let's go and see. I'm just going to replace it. And then I'm going to break that bracket. I'm seeing like terms, so these two are like terms. So that leaves me with a sine squared x plus Let's take a little deep dive here. Let's say that I replace sine of x, let's make that x, and cos of x, let's make that y. And I've got x squared plus xy minus 2y squared. Doesn't that look like that double variable quadratic equation? Yes, yes it does. So let's see if we can factorize this guy, and we can. So he becomes x, remember with the double variable, we just do our normal factorizing, we just ignore the fact that the y is there. So what we'll see is, we'll see this, and we can try and factorize this, and then this becomes, and then what we do, we just go and put that second variable at the back where it is here. But you can only do this if you've got a double variable. The powers must be half of whatever the front is and the back is when in descending order of powers. Okay, but how does that help us? Well, let's go back, because we're just going to replace everything with, so I've got sine of x minus cos of x, or 1 of cos of x, sine of x, and this looks like it's going to be 2 of those tan ones that we just looked at. Oh, this is going to be quite a terribly long one. Divide both sides by cos. Are we even going to fit on the page? Maybe. Okay, let's find the reference angle for tan of 1. Let's see, it's 45. And we are going to be in quadrant 1, which is just plus k times the period is 180. Or we're going to be in quadrant 3, which is just going to be 180 plus 45, 225 plus k, 180 k's. Great stuff. Let's look on this side. Remember, there's no restriction on the tan graph, because tan, if you had to graph it, it would be infinite. Reference angle here is 63, 43, and because it's negative, we are going to be in quadrant 2, which is 180 minus, so it's 116, 5 7 plus k times 180 k's. Let me fix that E. Or we're going to be in quadrant 4, which is going to be 360 minus that angle, which is 296.56. Yes, I'm going to write over this blue. Okay, that was quite intimidating, but it's doable. Okay, so we used both of our identities to try and fiddle with this question. So on this next slide, I've got 4 that I want you to do. These all come out of past papers, ranging from 2025 all the way back to, I think, 2011, that I've picked these out of. Do them. I will post the video shortly of how to do them, and yeah, let me know how it goes in the comments. Maybe what you can do is you can even post your solutions in the comments if you're feeling confident. Good luck. Have a good one, guys. Hopefully this video was helpful. Share it with your friends and have a good day.